Okay, my student. Now we'll talk about a three-phase system, experiment number 8 and 9. For experiment number 8, a small idea there, which is phase sequence for a three-phase. We'll start as we start discussing theory class about the three-phase system. We know that we have two type of sequence, either positive sequence or negative sequence. Positive sequence, which is A, B, C, and negative sequence A, C, B. If we draw three phase, since we know between each phase and phase in the current or voltage, there is 120 degree, okay? We have phase A and phase B, phase C. How to distinguish between positive sequence and negative sequence? We will put point here or star as observer, and we'll start rotate phases counterclockwise. Okay, if in this case positive sequence, this A and B, C, A will go through the observer first, and then B will come, and then C will come through the observer the last, because this we call it A, B, C. Here the opposite, here A and here C and here B. If we rotate the phases counterclockwise, okay, A will go through the star first, and then C, and then will become last, because this we call it A, C, B. This is the point from experiment phase sequence as a theory. Then we'll talk about three-phase circuit. We will have two type of circuit. We will have Y connection, okay, Y, or we can say star, as we mentioned in the theory class, okay. And the second one, it is delta connection. How to distinguish between delta and Y? You can see here all the end point for the load connected in one common point in the Y. For example, if I want to change the shape, not as a Y, if I draw like this, you will notice that all the end connected in one common point. This is considered as Y connection. Okay, sorry, Y connection. Okay, for delta, if you say this is start and this end, this is start, end, you will find end point connected to start point. End point for the second one, if we say this Z1, Z2, Z3, second end connected to the third start, third end connected to the first start, and then the power source coming here, A coming to the start 1, okay, the B coming to start 2, C coming to start 3. Okay, our experiment here, before we go to the experiment, we'll see the formula, use it, as also we mentioned this in the video for the theory class, but we will repeat it here. Okay, we have two type of voltage. We have voltage line, V line, from A to B or B to C or A to C. Okay, and also we have voltage, another voltage, which is called V phase, which is across each impedance. our system Z1 equals Z2 equals Z3. This is called balanced system. Okay. And V phase 1, it will equal V phase 2 equal V phase 3. Okay, as a magnitude, not in the angle. The angle, as we know, between each phase and the other, 120 degree. For V line 1 equal V line 2 equal V line 3. The relation between voltage line and voltage phase, as mentioned in the theory class, root 3. Okay, if you find value of V phase, you multiply by root 3, you will get value of V line. For example, in our class, 120 our phase, 4 to n or 5 to n or 6 to n. If you multiply by root 3, you will get 208, which is line value, 4 to 5, 5 to 6. Okay, for the current line here, if you go through like this, you will find the current line equal current phase in Y connection. I line equal I phase. Okay, this is the formula for Y connection. For the delta connection, it is the opposite. We can show this, but you can see here the point. This, if you connect voltmeter, this point for line voltage, this point equal this point, which is here, and this point equal this point, which is here. This means V line equal V phase. And for the current, the opposite, root 3. It is mentioned in the book and theory class how to find root 3, from where we found root 3 equal V, like this. Okay, this is the difference between Y and delta. It's mentioned also in the class, in the manual, line voltage at three-phase generator, it is VAB, okay, equal root 3 VAN. VAN, which is phase, multiplied by root 3, you will get VAB. Between each phase, each line and each phase, there is 30 degree. This is different story than 120. 120 between each phase and other, but 30 degree, it is the angle between each phase and line value. For phase voltage and line voltage. For example, let me draw the vector for you. EAN, and this EBN, and this ECN. Okay, between each phase and phase 120 degree. But if we need to draw the line value, you will find here there is 30 degree between the phase value and line value, which is EAB, and similar for the VBC and VCA. Okay, but I will show only one to clear the idea. Okay, this 30 degree coming from difference between phase and line. Okay, then if we need to find line voltage at three load, the difference between this and this is in the generator and this in the load. This is capital, this is small, but the same formula. Okay, I will show if we have the later. I will show to you source with the load. Then if we need to find phase voltage at the generator, it is division. Okay, VAN divide line divide by root 3 with the angle 30, and similar for phase voltage at load division. Okay. For the line and phase current, as we mentioned, it is equal in Y connection. This table for Y connection. Okay, it will be equal in value, magnitude, and the angle. VIA equal IAN in the magnitude and the angle, IB equal IB equal IBN in the magnitude and the angle, and so on. Okay. Now the experiment, we will connect Y connection, 3 resistor. Okay, we'll put in 400 ohm. Okay, and we will connect series ammeter for each phase. We will find the current I1 equal I2 equal I3, and E1 equal E2 equal E3, since it is balanced system. Unbalanced system we'll study in the other courses. Okay, we'll apply line to line voltage 280 and 400 ohm for each resistor, 400. Okay, you will find similar to near to this value. We will see in the our experiment later. After that, you need to answer the other question: what is the average value, what is the E1, E2, I1, all the other. Last thing, you will find B1 plus B2 plus B3 equal B total. Okay, this will apply for Y connection or delta connection. We will add all the power, and then we will find power total. Now we'll talk about delta load. Delta, the formula for the delta. This is the formula for the delta. The load current. Okay, the load current equal IAB. Okay, which is equal line value, or if you need to say this is the line and this is the load. And this similar to this, but this we will find the line value, and this we will find phase value. √3 multiplied by phase value minus 30 degree, you will find line value. If you need the opposite, you have the line value and you need to find phase value, divide √3 by 30 degree, and similar for the other. Okay, for phase value, all your calculation in theory or lab by phase value. If you need to find for example IA, which is line current, you cannot divide direct line current or multiply line current multiply by ZAB. You will get wrong answer. You need to multiply phase current multiply by Z, then you will find V phase. After that, you will you can use phase value to calculate line current. Okay, all your calculation by phase value in the beginning. Start with the phase value, even the power. Start your calculation by phase value. Don't use the line current, the line value. Okay, here other formula, line current, as we mentioned here, it is mentioned here. Okay, IA equal √3 I phase with 30 degree. Okay, IA, IB, IC, which is mean line current. The symbols here, you will find in the other book different symbol, but you need to consider what is this current, either line current or phase current. You will go to the other book, you will find different symbols. And as we mentioned, impedance equal, because our system is balanced system. Then we will connect two circuits in delta, one to find line current and the other to find the phase current which is going through the resistor, each resistor. This will give you I1, this will give you I2 which is going through R2, and this ammeter will give you I3 which is going through R3. In the end you will find I1 equal I2 equal I3, which is I phase. And for this circuit you will find I4 equal I5 equal I6, which is equal I line. Okay, since it is going through the line, and this going through the phase, each phase, because this we call it I phase, and this call it I line because it's going through the line. Okay, similar, you will find the value for E1 and I1, E2, I2, E3, I3. We will show it in the as practical. Okay, and you need to answer the other question. After that, connect the delta connection for finding I line. Also, you will find here it is 0.52 or 0.51, and here in the phase 0.3. If you multiply 0.301 multiply by root 3, you will get around 0.51. Okay, this means the line value and this phase value. Okay, and then you need to answer the question here for the test your knowledge. And the power, as we mentioned, B1 plus B2 plus B3, you will find B total.